for multiplying and dividing radicals is that you are going to multiply or divide the coefficients. Those are the numbers or terms in front of the radical sign. And then you're going to multiply or divide the radicands. That's what's underneath the radical. So basically the outside times the outside, the inside times the inside, or outside divided by outside, inside divided by inside. In this case, a little bit different than adding and subtracting, we do the operation first, and then we simplify at the end. So before, when we were doing adding and subtracting, we simplified first. And this is the complete opposite, so you have to make sure you get your rules straight. So when I'm looking at question number 1, in front of both of these two radicals are technically the number 1, which is why it's not written, because 1 times 1 would just give us 1. So I don't have an outside number or coefficient for either of those necessarily that I need to multiply. But I can do the 5 times 20, which is going to give me radical 100. And because both the 5 and the 20 are under the radical, the product of them, the 100, is under the radical as well. And then I'm going to simplify, and we know that the square root of 100 is 10. For question number 2, same rule applies. Here, though, we do have coefficients other than 1, so I'm going to multiply the negative 6 times the 5, which gives me negative 30. And then I'm going to multiply the radicals together. Radical 2 times radical 8 is radical 16. Remember, they're connected by multiplication. They're smushed together, so it's just implied. So when I go back now and actually do that multiplying, I want to simplify the radical 16 into 4, and then multiply that 4 by 30, which gives me negative 120. These two are both very easy examples. You can see as we move along here, the next one gets a little bit more involved because of the variables that are there. So this is 9 times technically 1, which is 9. Radical 10 times 30, 300. X to the third. Rule is that you add the exponents. Now I have to simplify. That means I'm going to take this 300x to the third, break that up into everything that's a perfect square and everything that's not. So factors of 300 are 103. X squared is perfect, the extra x is not. Remember, if there's an odd exponent, we split it up the most amount of evens we can, and then the one extra one that's there. Everything that's in the first radical, we can square root, so this is 9 times 10x. Radical 3x, nothing is going to happen with that radical 3x, it stays where it is, nothing can be square rooted. So this is 90x radical 3x for my final answer. And just like we've talked about over the past couple of days, it's not necessarily going to be the case that you can predict what your answers are going to look like. So we're going to turn the page, go on to the next one. I'm going to pick and choose the ones that I'm going to do here. I'm not going to do all of them. If you take a look at question number 4, I'm going to do that one just because it has those fractions in there, and I know that bothers some of you. So I'm multiplying the coefficient times the coefficient. So that's 2/5 times 3/4 radical, and then I'm going to do the 20 times the 10, which is 200. When I multiply those fractions together, 2/5 times 3/4, I'm going to reduce ahead of time. And when I do that reducing, I'm going to say 2 goes into 2 once and into 4 twice, which then at the end will give me, along the top, 1 times 3, which is 3. On the bottom, 5 times 2, which is 10. Radical 200. Now that 200 has to be simplified. I'm going to turn that into 100 in the first radical and 2 in the second, which will end up giving me 3/10 times 10, or 10 over 1, radical 2. So the square root of 100 is 10. And then I can cancel out the 10s. 10 divided by 10 is 1, and my final answer becomes 3 radical 2. For question 6, when we go through and do this one, this is very similar to lots of things you've done in the past. I have something out in front of the parentheses, connect to it by multiplication. 2 terms inside the parentheses, so I have to distribute. When I distribute the 2 radical 5 to 2 radical 5, I'm multiplying 2 radicals together, so I'm going to do the 2 times the 2, which is 4, the radical 5 times the radical 5, so radical 25 plus, and then I'm distributing this over to here, 2 radical 5 over to the 3. The 3 is basically an outside number. It gets multiplied by the 2, which is 6. The radical 5 does not have another radical to get multiplied to, so it's just going to carry along. Simplifying, I have 4 times 5 because the square root of 25 is 5. And then I can go back and multiply the 4 times 5 together. In the final answer on this one, 20 plus 6 radical 5, there's nothing else that I can do with that because the 20 is not a radical 5 term, so it cannot get connected to this. Sometimes people write down that the answer to that is 26 radical 5 because they try to combine them and you can't. They are unlike terms. So I'm going to go ahead and do question number 8 now. When I take a look at question number 8, this is also similar to something you've done in the past. You have 2 binomials separated from each other because they're wrapped in parentheses, and when I go through and do this, I have to FOIL. So if it helps you to draw those little loops there, go ahead and do that as a reminder. Some of you may need to do that. Some of you can probably do it in your head. So I've got 2 times 4, which is 8. 2 times radical 3, which is just 2 radical 3. The 2 is an outside number, the 3 is an inside number. They cannot be multiplied together. And then I do the inner loop, so that's minus 4 radical 3. And then the outers is going to give me minus radical 9. Radical 3 times radical 3 is radical 9, which is just 3. So I have 8. Combine these terms together, minus 2 radical 3, minus 3. And then I can combine these two together, which is going to give me 5 minus 2 radical 3. So just a little note here, when we multiply together the radical 3 times radical 3, that's radical 3 times radical 3, which is radical 9, which is going to be 3. So the rule for this is, as a little shortcut, if you're multiplying 2 radicals together that are exactly the same, you can basically just say that your answer is whatever the number is that's underneath that radical. For a question like number 9, this goes back to your algebra class. You want to make sure that if you have a set of parentheses that are squared, that you're writing them twice. So it's 3 minus radical 5 times 3 minus radical 5. As soon as you have it written like that, it's going to be a reminder to you that you are going through and foiling. So again, I've got this FOIL. Draw the loops if you need to. You may or may not need to. So when I go through and FOIL, I have 9 minus 3 radical 5. When I distribute the 3 to both of the parts, so I'm going to distribute it over to here and distribute it to here. And then the inners, which is right here, minus 3 radical 5. And then negative radical 5 times negative radical 5. A negative times a negative is a positive. And radical 5 times radical 5, that's that little shortcut we were talking about over here, is just going to give me a 5. I go back and combine like terms. The 9 plus 5 can be combined into 14. Minus 3 radical 5 minus 3 radical 5 gives me minus 6 radical 5. So although we're doing this with radicals, a lot of the things that you see here are things that came from your algebra class from last year, where you're talking about combining like terms, you're talking about foiling, you're talking about distributing. So I'm going to kind of switch now and go over into some of the division problems. And just like we did with the multiplication, I'm going to start on some of the easier ones first. So I'm going to start with question 11. I'm dividing in question 11. And the numbers that I'm dividing are both underneath the radical. Technically, there's 1s out front, but 1 divided by 1 is 1. So I'm dividing 72 by 2, which gives me 36. 72 and 2 are both under the radical, so 36 is under the radical as well. The square root of 36 is 6. Final answer on that one is a 6. For a question like number 12, we're again dividing. I'm going to do outside number divided by outside number, 8 divided by 2, which is 4. Inside number divided by inside number, that's 48 divided by 3, which is 16. Under the radical, because the 48 and the 3 were under the radical. When I go back to simplify this, I have 4 times, and then remember the square root of 16 is 4, so 4 times 4 gives me that 16. I'm going to go ahead and move along now to question 14. Question 14 does have some variables in there that we need to deal with. So in question 14, when I start this question, I'm going to work on the numbers that are out in front, and I see that I have 3 over 6. I can reduce this. 3 goes into 3 once and into 6 twice, so I know that I'm going to have a fraction of 1 over 2. There's a couple of different ways to approach this problem. It kind of depends on what you see. One of the things that I'm going to do now is I'm going to carry that 1/2 along, and I'm going to split up what I have on the top. So if I take a look at the top, I have a 16, and then I have a y to the 7th that I'm going to split into y to the 6th and y to the 1st. So everything here is perfect, everything here is not. And then I'm going to keep that division bar going, and I'm going to do the same thing on the bottom. So on the bottom, I have 25 y to the 2nd, the most amount of evens, and 1 leftover y that's over here. When I do that, one of the first things that I see is that I am now able to go back and reduce the fact that I have a radical y to the 1st and a radical y to the 1st, reduce them and cancel them. So that makes my life a little bit easier. And then from there, I'm going to go back and simplify my radicals. So I have a 1 on the top, a 2 on the bottom. Square root of 16 is 4. Square root of y to the 6th is y to the 3rd. On the bottom, square root of 25 is 5. Square root of y squared is y. So for my final answer on this one, I have 4y third over 10y. And then I look at that, and remember, the last step on the rules is to simplify whatever you can. So I've gone through, I've multiplied these back together that I have here and here. Now I just need to make sure that this is simplified completely. So as I look at that, I can see that I can still reduce further. So in other words, I can divide both the top and the bottom by 2, which will give me 2 over 5. And then I can also divide the y squared, on the bottom into y to the 3rd, which gives me y squared. So this then becomes my final answer when I simplify completely. There's a lot of stuff going on in that question, and there's a lot of stuff that you could do in different orders or look at a little bit differently. So I've done this numerous ways, numerous times. It usually just depends on what I see first on any given day. For question number 15, I'm going to do this one because most of the time kids think that this is a really difficult question, and it's actually really super easy. So when we're doing this particular question, I want you to notice that I can't divide the 32 and the 9, nor can I divide a number into both of those or divide both of those by a number. So there's no simplifying I can do with the 9 and 32. What I'm going to do, though, is I'm going to use one of the rules of division, which says if you have two things in fraction form divided or with a radical over them, I can divide that up and give both the top and the bottom their own radical. As soon as I do that, the bottom very quickly clears up to be a 3 because it's radical 9. The top, I'm going to split up that 32 into 16 and 2. And the reason why I'm doing that is because the square root of 16 is 4, so I have 4 radical 2 over 3 for my final answer for that one. So it actually goes pretty quick when you do that. You separate it top and bottom with both their own radical. All right, and then I'm going to go ahead and go on now to a couple of the last ones that we have here for division. These are all a little bit different because you have 2 terms on the top. You can see that there's 2 terms because they're all separated with either a plus or a minus, and 1 term on the bottom. So the rule for this is that you need to make sure that when you do this, you are getting the denominator to go with both parts in the numerator. So if I was looking at question 16, technically that radical 2 needs to go on both parts of the numerator. So some of you may prefer to just go through and write it like this and then do your division. So over here, when I divide, I get radical 4 plus radical 5. Square root of 4 is 2. So final answer, 2 radical 5. Sorry, 2 plus radical 5. You don't want to forget that plus sign in there. When I look at number 17, I realize that I technically am doing the same exact thing. So when I go in and I start working on this question, I've got 6 over 3 minus radical 27 over 3. Now the problem with this one is, although we can divide the 6 by 3 and get 2, we can't divide the 27 by 3 that we have here. This does not work. The 27 is under a radical and the 3 is not, so they're not set up to be able to be divided, only outside number by outside and inside by inside. So what I need to do is split that 27 up into radical 9, radical 3. And when I do that, I know the square root of 9 really is 3. And then what happens is that the 3's cancel out, and my final answer, when that 3 cancels out, is going to be 2 minus radical 3.
Mrs. Ridley, can you please call the office?
For number 18, same kind of idea. I've got to make sure that that 5x on the bottom applies to everything in the numerator. I'm going to go through this, and I'm going to start by separating it initially. Both of the two terms in the numerator have to be divided by that denominator of 5x. When I'm on the first term, working on that, 5 divided by 5 is 1, x to the 4th divided by x to the 1st is x to the 3rd, minus. Now over here, same thing. Radical on the top, not a radical on the bottom, so we've got to make sure we divide up the numerator. I'm going to split this up. Everything that's perfect in the first one, everything that's not in the second. So this will be 25 times 2. 25 is perfect, 2 isn't. They multiply to give me 50. X to the second is perfect, divided by 5x. So when I go through now and kind of simplify what I have here, when I take the square root of 25x squared, that gives me 5x, and I have a 5x on the bottom. So because the 5x is connected to the radical 2 by multiplication, it makes it legal for me to go through and cancel this 5x and this one, which leaves me with a final answer of x to the 3rd minus radical 2.